Hey, welcome back. We are looking at wrapping up our kind of math unit here, and we got one big piece left to the puzzle. We've been spending a lot of time talking about how we start to round our digits based on our precision of our measurements. We've talked about now how we can start to use our metric system, all base 10, to be able to go from one prefix to another. And now we're ready to bring it all together and talk about, okay, now that we know all these tools, we got all these different tools we can use for math in our mathematical calculations. How do we actually plug it all together? And that's what we're talking about today. Today, we're just going to introduce dimensional analysis. There'll be some questions along the way here that'll pop up and kind of have you interacting. But I really just kind of want to get you thinking about this so that we can come back on whenever I see you again and really kind of hit the ground running is kind of the plan. So if it was me, I'll let you know when we start taking some notes and when I want you to record stuff. Feel free to pause it at any point, and then you can go back and re-hit it. But yeah, let's take a look. Dimensional analysis, it's sometimes known as the factor label method. All that to say, how are we going to calculate? How are we going to run our math in our chemistry class? And that's all this is. But before we do that, let's see if I break math. Does this break math? So if I said to you 12 eggs equals blank, hopefully you would say 12 eggs equals a dozen. Great. If I said 60 minutes equals, you'd say 1 hour. If I said 24 hours equals, you'd say 1 day. And so these are all what we call equality statements, two things that are set equal to each other. And these are going to be important to us as we start to think about kind of this dimensional analysis and how it plays together. But these are equality statements. These are kind of different equal statements. But if I take a number, so if I took 2 and divided by 2, it would equal, hopefully you all said 1. We know that a value divided by itself is always going to equal 1. Well, what if I took the amount of time that is 60 minutes and divided by the amount of time that is 1 hour? Because we said before 60 minutes equals an hour. So if I divide those two things that are equal, I still get 1. Right? The amount of time that is 60 minutes divided by the amount of time that is 1 hour equals 1. And I can flip it, right? If I said, well, what's 1 hour? Sorry, units, important, forgot them. If I said 1 hour divided by 60 minutes, again, those two times are equal. They're different units, but they are equal amounts of time. And so it still equals 1. And I hear you say, why do I care about this? Well, when we start to think about how we can change our units, we got to be using these equality statements because we can take any value. I'm going to call it n here. I don't want to use x because it looks too much like multiplication. If I took some value n and I multiplied it by 2 over 2, for example, well, 2 over 2 is 1. N times 1 is still just n. And this is important mathematically and scientifically because this means I can take whatever I want and multiply it by 1, however many times I want, and the thing I measured doesn't change. It might change in units, but the quantity we measured at the beginning remains the same because all our equality statements equal 1 when we divide them by themselves. And this leads us to our dimensional analysis. So if I was taking notes, here's the part I would get. So dimensional analysis is just a tool. It is a system for solving multi-step calculations, which is wonderful. It is, and I get it. At the beginning here, this is going to feel cumbersome and it's going to feel kind of icky, and that's okay. But hopefully I can sell you on the fact that once we get proficient at this, once we get comfortable with it, we're going to be able to solve incredibly in-depth problems, multiple step problems, all in one go in our calculator. Instead of do a problem, write it down, do a problem, write it down, do a problem. No, we can do it all in one go and be done. And our final rounding will be more precise because we didn't round multiple times. But more on that later. It is going to use these equality statements. We use them as conversion factors, if you will. And so because they equal each other, we can divide. It's always equal to 1 because those two things are equal to each other. And so kind of the streets along the way, if you will, if we're thinking about it like MapQuest, your steps for converting are always going to have to be using these equality statements, these things that equal each other. And then as you're kind of running it, your units have to cancel diagonally. The only units that remain, once all is said and done, once we set it all up, we run all the math, the only units left should be the units that you wanted. And so it's going to be a really easy for us, and this is again the power of the system, it's really easy to see whether or not we did the math right, because the only unit that will remain is the unit we were looking for. And so not only can we see all of our work in one go, we know it's all set up correctly because the units all canceled. The final process or the final answer is all going to be one calculation in the end. So if we get comfortable with this, it's really going to save us a lot of time in the long run. But don't worry, we're going to have a lot of practice at this. So let me give you an example, right? And I'm going to take it all the way back, right? So if I wanted to know how long is a typical Simpsons episode in hours, including commercial breaks, because I want a clean number. So one episode's including commercials and the credits runs for 30 minutes. How long is this in hours? Well, you always start with your given. So from our question, we got 30 minutes. That's our given. We always start with that. And I like to always put it over 1 just to keep it in the numerator so I can kind of see where that number is and keep track of its place. Because now I want to change its unit. And I know you're all screaming at me going, that's a half an hour, Jorgensen. Why are we doing this? Because again, I want to show you the system. I get it. You know that that's half an hour. You already have the answer, but let me show you how we would do this. So we've got our given, and we know we want to end up in hours. So I always like to put that at the end. I'll do this more in class, but usually I put the target at the end, and then I think about my units. Well, I'm in minutes. I want to get to hours, so I need some relationship. Do I know a relationship between minutes and hours? Well, yeah. I know that there are 60 minutes in 1 hour. And so that becomes our conversion factor. We want our units to cancel diagonally. We've got minutes up top in the first part. I'm going to put my minutes in the bottom in the second part. My hour goes on top, right? 1 hour divided by 60 minutes. Well, this is just 1. I can multiply whatever I want by 1. That's not going to change the length of the Simpsons episode. It's just going to change the units it's reported in. And if our minutes are across from each other, those units actually cancel, right? Because one's on top, one's on bottom when we start to math here. Now the units cancel, not the numbers, right? So the 30 stays. So if we were going to solve this, we would first stop and say, okay, is the unit that remains the unit that I wanted? It is. We wanted hours, right? That's the only unit that didn't cancel out. And now to solve, I would multiply my numerator, multiply my denominator, and divide. What's nice about this problem, well, 30 times 1 is just 30. 30 divided by 60 gives you the 0.5, half an hour. And again, I know you knew this, but I really wanted you to see how we would set this up because oftentimes we have more involved calculations. So for example, if we, and here's actually going to be your exit or your entrance ticket for when I see you next. When you come to see me, I want to see your age in seconds. That is what I need to see. Good news, I'm going to set it up for you. You just got to figure out how you would actually calculate it. So you always start with your given. So you would start with your age in years, right? You 15, 16, whatever your age might be, right? So we're starting with that. We're putting it over 1. And then again, if I was in class, if you're doing this live, all the way at the end, I would put just seconds because I want to get it to seconds. Well, what do I know about years? I need something with years. I know years to days, right? And so because years are in top, they go in bottom in our next step. They're always going to go diagonally across from each other in these setups. I know that 1 year equals 365.25 days. Don't worry, the 0.25 is actually going to round out with sig figs. More on that to come. But this is just 1, right? This number is 1. And if I were to stop right now, my answer would be in days. And that's not what I'm looking for. I'm looking for seconds. So I think again, I go, okay, what do I know about days? I know that in 1 day, there's 24 hours. Again, this is 1. The time that is 24 hours divided by the time that is 1 day is 1. And I can multiply by 1 however many times I want until I get the units that I want, right? And next I go, okay, hours. I know that 1 hour is 60 minutes. I'm close. And I know that 1 minute is 60 seconds. And if I could annotate, I don't have my tablet, sorry, my years would cancel, my days would cancel, hours would cancel, minutes would cancel. All of the units would cancel except for the one that I want. So I know I'm done because everything canceled except the units, seconds. Now I just got to math it. Well, the denominator is easy. 1 times 1 times 1 times 1 times 1. Don't have to worry about it. So if you take your age and multiply it by all the values in the numerator, you will solve a 4-step calculation in one go. And then you'll be able to round your final answer to match your sig figs of your measurement, which I think is gonna be two sig figs in your answers. I need this when I see you in class next.